darkness. That's what you'd see if you gazed out into the vast expanse of space. No stars, no galaxies, no light. Just an endless void. But that's not what we see. We see a universe teeming with life, filled with galaxies, stars, and planets. A universe that's still expanding, still growing. But what drove this expansion? Honestly, nobody really knows why. We do know that the universe began as a singularity, an infinitely hot and dense point. It expanded rapidly, and as it did, it cooled. Particles formed, then atoms, and eventually the first stars and galaxies. But the universe didn't stop expanding. It kept growing, and it's still growing today. Galaxies are moving away from us and from each other. The universe is vast, and it's getting vaster by the second. We're talking billions of galaxies, each containing billions of stars. The scale is almost incomprehensible. It's hard to wrap your head around the fact that we're just a tiny part of this vast expanse. Consider the Andromeda Galaxy, our closest galactic neighbor. It's approaching us at a speed of about 250,000 miles per hour. But even at that speed, it'll take over 4 billion years to reach us. That's how vast the distances are between galaxies. And yet, despite these distances, we can see them. We can study them, learn from them. The universe is full of mysteries. We don't know what dark matter is, or what dark energy is. We don't know how the universe began, or how it will end. But we're trying to find out. We're using telescopes, space missions, and particle accelerators to uncover the secrets of the universe. One of the most fascinating areas of study is the cosmic microwave background radiation. This is the residual heat from the Big Bang, and it's a key tool for understanding the universe's early stages. By studying this radiation, we can learn about the universe's composition, its density, and its evolution. It's a window into the past, a glimpse of what the universe was like in its earliest moments. But the universe is not just about the past. It's also about the present and the future. We're seeing new stars and galaxies forming, even as we speak. We're witnessing the dance of celestial bodies, the gravitational ballet that shapes the universe. And we're trying to predict what the future holds. Will the universe keep expanding, or will it collapse? Will we eventually reach the edge of the universe, or is there no edge? The questions are endless, and the answers are elusive. But that's what makes the universe so fascinating. It's a puzzle, a mystery that we're trying to solve. And as we explore, as we discover, we're forced to confront our own place in the universe. We're forced to ask ourselves, what are we in the grand scheme of things? Are we just a tiny part of a vast, uncaring universe, or is there something more? As we journey through the cosmos, we'll encounter more questions than answers. We'll see the beauty of stars and galaxies, but also the violence of supernovae and black holes. We'll be forced to confront the reality of our own mortality and the mortality of the universe itself. But that's what makes this journey so important. It's a journey of discovery, of exploration, and of self-discovery. So join me as we embark on this journey through the vast expanse of space and time. But be warned, the universe is full of secrets, and not all of them are easy to uncover. In fact, the more we learn, the more we realize how little we know. And that's what leads us to the biggest question of all. What lies beyond the edge of the universe? The universe is a mystery, and we're just starting to scratch the surface. But as we delve deeper, as we explore further, we'll uncover secrets that will challenge our understanding of the cosmos. And that's what makes this journey so exciting. The universe is full of surprises, and we're just starting to discover them. So, what's next? What secrets will we uncover, and how will they change our understanding of the universe? The answer, much like the universe itself, remains a mystery. To be continued. As we continue to unravel the mysteries of the universe, we find ourselves at the threshold of the most fundamental question of all. What sparked the creation of our cosmos? The answer, much like the universe itself, is shrouded in mystery. But one theory has emerged as the most widely accepted explanation: the Big Bang. This concept proposes that the universe began as a singularity, an infinitely hot and dense point, around 13.8 billion years ago. From this singularity, the universe expanded rapidly, and as it did, it cooled, allowing the formation of subatomic particles such as protons, neutrons, and electrons. As the universe continued to expand and cool, these subatomic particles began to come together, forming atoms, primarily hydrogen and helium. This process, known as Big Bang nucleosynthesis, occurred when the universe was just a few minutes old. And it's responsible for the abundance of light elements we see today. But the universe was still far from being hospitable to life as we know it. It was a vast, swirling expanse of hot, dense gas, with temperatures and densities that would be catastrophic to any living organism. As the universe expanded, it began to cool, and the first subatomic particles started to coalesce into larger structures. Gravity played a crucial role in this process, drawing matter together, and eventually the first stars and galaxies began to form. These ancient stars were massive, and they burned through their fuel quickly, ending their lives in spectacular supernovae explosions. These explosions scattered heavy elements throughout the universe, providing the raw materials for the formation of new stars, planets, and, eventually, life. But honestly, nobody really knows why the universe unfolded in this particular way. What sparked the Big Bang? What determined the fundamental laws of physics that govern our cosmos? These questions remain some of the greatest mysteries of our time, and scientists continue to grapple with them, seeking answers in the farthest reaches of the universe. As we delve deeper into the mysteries of the cosmos, we begin to realize that our understanding is still in its infancy. The universe is a complex, ever-evolving tapestry with threads of space and time intricately woven together. As we explore the cosmos, we're forced to confront the limits of our knowledge and the vast expanse of the unknown. It's a humbling experience, one that challenges our perceptions and pushes us to the boundaries of human understanding. And yet, it's this very uncertainty that drives us forward, fueling our curiosity and inspiring us to continue exploring the vast, uncharted territories of the universe. As we continue to explore the universe, we're reminded of the profound impact that our discoveries have on our understanding of the cosmos. From the formation of the first stars and galaxies to the evolution of life on Earth, each new finding sheds light on the intricate web of relationships that binds the universe together. And yet, despite our advances, we're still left with more questions than answers. What lies beyond the reaches of our observable universe? What secrets remain hidden in the farthest corners of the cosmos? The universe, it seems, is full of mysteries waiting to be unraveled. And as we stand at the threshold of this vast, uncharted expanse, we're reminded of the awe-inspiring complexity and the profound beauty of the cosmos. But as we gaze out into the void, we're also reminded of the universe's indifference to our existence. We're just a small part of a much larger whole, a fleeting moment in the grand narrative of the universe. And in this realization, we're left with a sense of quiet dread. A feeling that we're but a tiny, insignificant speck suspended in a vast, uncaring universe. This feeling of insignificance is precisely what drives us to seek a deeper understanding of the universe, to grasp the underlying mechanisms that govern its behavior, and to unravel the mysteries of space-time. Gravity and the speed of light. As we delve into the realm of space-time, we find ourselves confronted with a concept that is both familiar and yet utterly alien. Space-time, a fabric that weaves together the threads of space and time, is not just a passive backdrop for the universe's grand drama, but an active participant, shaping the motion of objects and warping the very fabric of reality. Consider, for instance, the phenomenon of gravitational time dilation, where the passage of time is slowed near massive objects, such as black holes or neutron stars. This effect, predicted by Einstein's theory of general relativity, has been observed in the real world, and has profound implications for our understanding of the universe's large-scale structure. As we explore the concept of gravity, we're forced to confront the reality that it's not just a force that attracts objects with mass, but a curvature of space-time itself. The more massive the object, the greater the curvature, and the stronger the gravitational pull. This understanding has led to a profound shift in our perception of the universe. From a static, unchanging backdrop to a dynamic, ever-evolving landscape, where gravity plays a central role in shaping the motion of galaxies, stars, and planets. Take, for example, the case of the Milky Way galaxy, which is thought to contain hundreds of billions of stars, all held together by the gravitational force. The galaxy's rotation curve, which describes how the speed of stars orbiting the galaxy changes with distance from the center, is a key piece of evidence for the existence of dark matter, a mysterious substance that makes up approximately 27% of the universe's total mass energy density. The speed of light, a fundamental constant in the universe, serves as a universal speed limit, governing the pace of all physical phenomena. As we approach this speed, time appears to slow, and the laws of physics begin to bend and warp, revealing the strange and counterintuitive nature of reality. Honestly, nobody really knows why the speed of light is what it is, or what lies beyond the veil of space-time. But it's this very mystery that drives us to continue exploring, to push the boundaries of our understanding and to unravel the secrets of the cosmos. Consider the phenomenon of gravitational lensing, where the light from distant galaxies is bent and distorted by the gravitational field of foreground objects, such as galaxy clusters. This effect can be used to study the distribution of mass and energy in the universe, and has led to a greater understanding of the role of dark matter and dark energy in the universe's evolution. As we delve deeper into the mysteries of space-time, gravity, and the speed of light, we're forced to confront the reality that our understanding is incomplete, and that there are still many unanswered questions. What lies beyond the event horizon of a black hole? What is the nature of dark matter and dark energy? And what is the ultimate fate of the universe? These questions, and many more, remain shrouded in mystery, waiting to be uncovered by the next generation of scientists, theorists, and explorers. The search for answers will take us to the farthest reaches of the universe, from the cosmic microwave background radiation to the most distant galaxies, and will require the development of new technologies, new theories, and new ways of thinking. The universe, it seems, is full of secrets, and we're just beginning to scratch the surface. As we continue to explore, to discover, and to push the boundaries of our understanding, we're reminded that the universe is a complex, dynamic, and ever-evolving system, governed by laws that are both beautiful and brutal. And it's this very complexity, this very brutality, that makes the universe so fascinating, so captivating, and so worthy of our continued exploration. But as we stand at the threshold of this new frontier, we're also reminded that the universe is indifferent to our existence, and that our understanding is but a small, fleeting moment in the grand narrative of the cosmos. So we're left with a question: what lies at the edge of the universe, where the fabric of space-time is stretched to its limits, and the laws of physics begin to break down? And it's this question, this mystery, that will drive us to continue exploring, to continue discovering, and to continue pushing the boundaries of our understanding as we journey deeper into the unknown. But for now, the answer remains shrouded in mystery, waiting to be uncovered by the next generation of scientists, theorists, and explorers. And so we're left with only one option: to keep exploring, to keep discovering, and to keep pushing the boundaries of our understanding as we venture deeper into the vast, uncaring universe. As we venture deeper into the vast, uncaring universe, we find ourselves at the threshold of a new realm of exploration. One that takes us to the farthest reaches of the cosmos, where galaxies and galaxy clusters reign supreme. The sheer scale of these structures is awe-inspiring. With galaxies stretching across hundreds of thousands of light years, and galaxy clusters spanning millions of light years, held together by the invisible threads of gravity. But what's even more fascinating is the diversity of galaxies, each with its own unique characteristics. From the majestic spirals to the irregular dwarfs, and the giant ellipticals that dominate the cosmos. Honestly, nobody really knows why galaxies come in such a wide range of shapes and sizes. But one thing is certain: dark matter plays a crucial role in their formation and movement. This mysterious substance, which makes up about 27% of the universe's mass-energy density, provides the gravitational scaffolding for normal matter to cling to, allowing galaxies to form and evolve over billions of years. But dark matter is not the only player in the game. Dark energy, a mysterious component that drives the acceleration of the universe's expansion, also influences the distribution of galaxies and galaxy clusters on large scales. As we delve deeper into the world of galaxy clusters, we find ourselves confronted with some of the most extreme environments in the universe. These clusters are the largest gravitationally bound structures in the cosmos, containing thousands of galaxies, as well as vast amounts of hot, ionized gas that fills the space between them. But what's even more remarkable is the way these clusters are distributed throughout the universe, forming a web-like pattern of galaxy filaments and voids that stretches across billions of light years. It's as if the universe is a vast, intricate network, with galaxies and galaxy clusters serving as the nodes and hubs that connect the cosmos. But how do these galaxy clusters form, and what role do they play in the evolution of the universe? To answer these questions, we need to look at the distribution of galaxy clusters on large scales, and how they're affected by the interplay between dark matter and dark energy. One of the key observational tools for studying galaxy clusters is the cosmic microwave background radiation, which provides a snapshot of the universe when it was just 380,000 years old. By analyzing the tiny fluctuations in the CMB, scientists can infer the distribution of matter and energy in the universe, including the locations of galaxy clusters and the vast networks of galaxy filaments that connect them. As we explore the universe, we begin to realize that the distribution of galaxy clusters is not random, but rather follows a complex pattern that's influenced by the underlying structure of the cosmos. This pattern is reflected in the way galaxy clusters are grouped together, forming superclusters that stretch across hundreds of millions of light years. It's a remarkable sight. With galaxies and galaxy clusters arranged in a delicate balance of gravity and expansion, like a cosmic dance that's been unfolding for billions of years. But what's even more intriguing is the role that galaxy clusters play in the evolution of the universe. These clusters are not just passive observers. They are actively involved in the process of galaxy formation and evolution, with the hot gas between galaxies serving as a reservoir for star formation and the growth of supermassive black holes. It's a complex, dynamic process that's still not fully understood, but one thing is certain. Galaxy clusters are the key to unlocking the secrets of the universe's large-scale structure. As we continue to explore the universe, we're reminded that there's still so much we don't know, and that the cosmos is full of mysteries waiting to be uncovered. But by studying galaxy clusters and the large-scale structure of the universe, we're taking a crucial step towards understanding the intricate web of relationships that binds the cosmos together. And as we journey deeper into the unknown, we're invited to subscribe to this channel, where we'll continue to explore the universe, one mystery at a time, and anchor our frequency in the midst of algorithmic noise. And now, as we pause to reflect on the vast expanse of the universe, we're left with a quiet, unsettling realization. We're just a small part of a much larger cosmic landscape, and the universe is still full of secrets waiting to be uncovered. As we stand at the edge of this vast cosmic landscape, the universe stretches out before us like an endless starry canvas, with galaxies and galaxy clusters scattered across it like diamonds on black velvet. The realization that we're just a small part of this grand tapestry is both humbling and awe-inspiring. And it's a feeling that's only deepened by the discovery of the universe's expansion. Honestly, nobody really knows why the universe is expanding, but we do know that it's been accelerating for billions of years, with galaxies moving away from each other at incredible speeds. This phenomenon was first observed by Edwin Hubble, who in the 1920s discovered that the light coming from distant galaxies was shifted towards the red end of the spectrum, a phenomenon known as redshift. This redshift is a result of the galaxies moving away from us, and the farther away they are, the faster they're moving. It's a bit like listening to a siren as it speeds away from you. The pitch gets lower and lower as it disappears into the distance. Hubble's observations led to the development of Hubble's law, which states that the velocity of a galaxy is directly proportional to its distance from us. But what does this mean for our understanding of the universe? Well, for one thing, it suggests that the universe is still evolving, with galaxies moving away from each other and new ones forming all the time. It's a dynamic, ever-changing landscape, and one that's full of mysteries waiting to be uncovered. Take, for example, the case of the galaxy GNZ11, which is seen as it was just 400 million years after the Big Bang. The light from this galaxy has been traveling through space for over 13 billion years. And yet it's still visible to us today. A reminder of the incredible distances and timescales involved in the universe. As we delve deeper into the universe, we're forced to confront the reality of our own insignificance. We're just a small part of a much larger cosmic landscape, and one that's governed by laws and forces beyond our control. The universe is indifferent to our existence, and yet it's this very indifference that makes it so fascinating. We're drawn to the universe like moths to a flame, helpless to resist its beauty and its mystery. And as we continue to explore the cosmos, we're reminded of the infinite possibilities that lie beyond our small planet. Possibilities that are both exhilarating and terrifying. But what lies beyond the edge of the observable universe? Honestly, nobody really knows. The universe may be infinite, or it may be finite, but bounded by some unknown mechanism. The truth is, we just don't know. And it's this lack of knowledge that drives us to continue exploring, to continue pushing the boundaries of what we know. The universe is a puzzle, and we're just starting to uncover the clues. As we move forward, we're forced to confront the reality of our own limitations, and the fact that we may never have all the answers. And yet, it's this uncertainty that makes the journey so compelling, so necessary. So, what's the next step in our journey through the cosmos? How do we uncover the secrets of the universe, and what do we hope to find? The truth is, we're not just searching for answers. We're searching for a sense of connection, a sense of belonging to something greater than ourselves. We're searching for a way to understand our place in the universe, and to find our way in the vast expanse of space and time. And as we move forward, we're reminded that the universe is full of mysteries, and that the journey itself is the destination. But for now, we're left with a haunting question. What lies beyond the edge of the observable universe, waiting to be discovered? As we ponder the mysteries that lie beyond the edge of the observable universe, we're drawn back to the cosmic microwave background radiation. The residual heat from the Big Bang that still echoes through the vast expanse of space and time. This faint glow, a whisper from the universe's infancy, holds the secrets of the cosmos's early stages and its large-scale structure. Honestly, nobody really knows why the cosmic microwave background radiation is so crucial to our understanding of the universe, but it's clear that it's a vital piece of the puzzle. The cosmic microwave background radiation is thought to have originated around 80,000 years after the Big Bang, when the universe had cooled enough for electrons and protons to combine into neutral atoms. This era, known as the recombination era, marked a significant milestone in the universe's evolution, as it allowed photons to travel freely through space, carrying with them information about the universe's temperature and density fluctuations. These fluctuations, in turn, would give rise to the vast galaxy clusters and superclusters that we see today, a testament to the universe's inherent complexity and beauty. But what's truly fascinating about the cosmic microwave background radiation is its uniformity. The temperature of the radiation is almost identical throughout the universe, with tiny fluctuations of just 1 part in 100,000. This uniformity is a mystery, as it suggests that the universe was once in a state of thermal equilibrium, with all parts of the universe in contact with each other. However, as we've discussed before, the universe is vast and expanding, making it difficult to understand how this equilibrium was achieved. One possible explanation is that the universe underwent a period of rapid expansion, known as inflation. In the very early stages of its evolution, this inflation would have smoothed out any irregularities in the universe, creating a uniform temperature and density throughout. However, the exact mechanisms driving inflation are still unknown, and scientists continue to debate the details of this theory. As we delve deeper into the mysteries of the cosmic microwave background radiation, we're reminded that the universe is full of unanswered questions. The more we learn, the more we realize how little we know, and the more we're driven to continue exploring and seeking answers. The cosmic microwave background radiation is just one piece of the puzzle, but it's a crucial one, offering a glimpse into the universe's early stages and its large-scale structure. The study of the cosmic microwave background radiation has led to some remarkable discoveries. For example, the Cosmic Background Explorer (COB) satellite, launched in 1989, provided the first detailed maps of the radiation, revealing tiny fluctuations in temperature and density that seeded the formation of galaxies and galaxy clusters. More recent missions, such as the Planck satellite, have built on these findings, providing even more precise measurements of the radiation and its properties. As we analyze the data from these missions, we are beginning to uncover the secrets of the universe's early stages. We're learning about the formation of the first atoms, the creation of the first stars and galaxies, and the evolution of the universe's large-scale structure. But with each new discovery, we're also reminded of the universe's inherent complexity and mystery. The cosmic microwave background radiation is a powerful tool for understanding the universe. But it's just one part of a much larger puzzle. The universe is a vast and complex system, with many interacting components and processes. As we seek to understand the cosmic microwave background radiation, we're forced to confront the limits of our knowledge and the uncertainty of our theories. Honestly, nobody really knows what the universe was like in the very early stages of its evolution, or what drove the formation of the first stars and galaxies. But by studying the cosmic microwave background radiation, we're able to glimpse the universe's early stages and to begin to understand the processes that shaped its evolution. As we move forward, we're reminded that the universe is full of mysteries and that the journey itself is the destination. The cosmic microwave background radiation is just one piece of the puzzle. But it's a crucial one, offering a glimpse into the universe's early stages and its large-scale structure. And as we continue to explore and seek answers, we're drawn back to the haunting question: what lies beyond the edge of the observable universe, waiting to be discovered? In the silence of space, the cosmic microwave background radiation whispers secrets of the universe's past, a reminder of the mysteries that still await us. And as we stand at the edge of the observable universe, we're left with a quiet, unsettling realization: the universe is vast, and we are small. A fleeting moment in the grand tapestry of time. As we stand at the edge of the observable universe, this realization sparks a profound curiosity about the unseen forces that shape the cosmos, particularly the enigmatic duo of dark matter and dark energy, which together comprise about 95% of the universe's total mass-energy budget. These mysterious components are thought to play a crucial role in the universe's expansion, with dark energy driving the accelerating growth of the cosmos, while dark matter provides the gravitational scaffolding for galaxy formation and clustering. But honestly, nobody really knows why dark matter and dark energy exist, or what their true nature is, leaving us with a vast, uncharted territory of ignorance that beckons exploration and discovery. One of the most compelling pieces of evidence for dark matter's existence comes from the observation of galaxy rotation curves, which describe how the speed of stars orbiting a galaxy changes with distance from the center. In the 1970s, astronomers like Vera Rubin and Kent Ford measured the rotation curves of several galaxies, expecting to see a gradual decline in star velocities as they moved further away from the center, due to the decreasing gravitational pull of the visible matter. However, to their surprise, the rotation curves remained flat, indicating that stars in the outer regions of the galaxy were moving at a much higher speed than expected, as if they were being gravitationally pulled by a large, unseen mass of dark matter. This discovery sparked a flurry of research into the properties of dark matter, with scientists proposing a range of theories to explain its behavior. From WIMPs, weakly interacting massive particles to axions, and even more exotic possibilities like sterile neutrinos. However, despite decades of effort, dark matter remains a ghostly presence, detectable only through its gravitational influence on visible matter, leaving us with a profound sense of mystery and intrigue. And as we delve deeper into the universe's large-scale structure, we find that dark matter's role is not limited to galaxy formation, but also plays a crucial part in the distribution of galaxy clusters and superclusters, which are the largest known structures in the universe. The story of dark energy is equally fascinating, with its discovery in the late 1990s revolutionizing our understanding of the universe's expansion. By observing the light curves of distant supernovae, scientists like Saul Perlmutter, Adam Rees, and Brian Schmidt found that the expansion of the universe was not slowing down, as would be expected due to the gravitational pull of matter, but was instead accelerating, driven by a mysterious negative pressure that pushes matter apart. This discovery was a shock to the scientific community, as it challenged our understanding of the universe's fundamental laws and raised more questions than answers, such as what is the nature of dark energy, and how does it interact with normal matter? As we continue to explore the universe, we're confronted with the unsettling realization that our current understanding of physics is incomplete, and that there may be new, undiscovered laws of nature that govern the behavior of dark matter and dark energy. The search for answers is an ongoing, iterative process, with scientists using a range of observational and theoretical tools to probe the properties of these mysterious components. From the Sloan Digital Sky Survey to the latest generation of particle accelerators. And as we stand at the threshold of this new frontier, we're left with a haunting question: what other secrets lie hidden in the universe, waiting to be uncovered? And how will our understanding of dark matter and dark energy shape our future exploration of the cosmos? As we venture deeper into the universe, another enigma emerges, one that has captivated human imagination for centuries: black holes. These cosmic monsters, with their unforgiving gravity and abyssal voids, have become a focal point of research. As scientists seek to unravel the mysteries of their formation, growth, and influence on the universe, honestly, nobody really knows why black holes come in such a wide range of sizes. From small, stellar mass black holes formed from the collapse of individual stars to supermassive black holes found at the centers of galaxies, with masses millions or even billions of times that of our Sun. The journey to understand black holes begins with their formation. It's a complex process involving the collapse of massive stars, whose gravity is so strong that not even light can escape once it falls within a certain radius, known as the event horizon. As matter accretes onto the black hole, it heats up, emitting intense radiation, which can be detected from great distances, providing astronomers with a way to study these elusive objects. But what's truly fascinating is how black holes interact with their surroundings, influencing the growth and evolution of galaxies, and even shaping the large-scale structure of the cosmos. One of the most striking examples of black hole influence can be seen in the galaxy Messier 87, or M87. Located about 55 million light-years from Earth, M87 is a giant elliptical galaxy, with a supermassive black hole at its center, weighing in at a staggering 6.5 billion times the mass of our Sun. This behemoth is responsible for the galaxy's unusual shape, with a vast, swirling disk of hot, dense gas and a jet of energetic particles stretching out for thousands of light-years. The black hole's gravity has essentially sculpted the galaxy, creating a complex, dynamic system, with matter and energy flowing in and out of the black hole's grasp. But black holes are not just passive objects sitting at the centers of galaxies. They're also active participants in the universe's evolution. Through a process known as quasar activity, supermassive black holes can release enormous amounts of energy in the form of light, heat, and kinetic energy, which can impact the surrounding intergalactic medium and even influence the formation of stars and galaxies. This energy release can be so powerful that it creates a kind of feedback loop, where the black hole's activity regulates the growth of the galaxy, preventing it from becoming too massive and maintaining a delicate balance between matter and energy. As we delve deeper into the world of black holes, we begin to realize the profound impact they have on the universe, from shaping the growth of galaxies to influencing the large-scale structure of the cosmos. Black holes play a crucial role in the grand symphony of creation. And yet, despite all that we've learned, there's still so much that remains unknown. Honestly, nobody really knows how black holes evolve over time or what role they play in the universe's ultimate fate. The search for answers will continue as scientists push the boundaries of human knowledge and venture further into the unknown, driven by an insatiable curiosity about the cosmos and our place within it. The study of black holes has also led to some remarkable discoveries, such as the detection of gravitational waves, which are ripples in the fabric of space-time, produced by the merger of two massive objects such as black holes or neutron stars. This breakthrough has opened up a new window into the universe, allowing us to study cosmic phenomena in ways that were previously impossible. And as we continue to explore the universe, we're reminded of the awe-inspiring complexity and the profound mysteries that still await us. The universe, it seems, is full of secrets. And black holes are just one of the many enigmas that we're still struggling to understand. As we stand at the threshold of this new frontier, we're left with a haunting question. What other secrets lie hidden in the universe, waiting to be uncovered? The search for answers will continue, driven by human curiosity and the desire to understand the cosmos and our place within it. And as we venture deeper into the unknown, we're reminded of the universe's indifference, its vastness, and its power. The quiet dread that settles in as we contemplate the mysteries of the universe is a reminder that we're just a small part of a much larger whole. A whole that's still full of secrets and still full of wonder. As we stand at the edge of this vast expanse, gazing out into the unknown, the universe's large-scale structure begins to reveal itself. A complex web of galaxy filaments and voids that stretches across billions of light years. A testament to the unforgiving power of gravity and the unrelenting expansion that has shaped the cosmos into its current form. Honestly, nobody really knows why the universe evolved into this intricate pattern. But scientists have made significant progress in understanding the underlying mechanisms that drive this process. The distribution of galaxies and galaxy clusters is not random, but rather it follows a distinct web-like pattern, with dense regions of galaxies and galaxy clusters forming the nodes and filaments, while vast empty regions, known as voids, make up the majority of the universe's volume. This large-scale structure is thought to have evolved over billions of years. As matter and energy interacted and influenced each other, giving rise to the complex landscape we observe today. One of the key factors in shaping this structure is the interplay between normal matter, which makes up only about 5% of the universe's total mass energy density, and dark matter, which accounts for approximately 27% of the universe's mass energy budget. The presence of dark matter can be inferred through its gravitational effects on normal matter, and it plays a crucial role in the formation and evolution of galaxies and galaxy clusters. The universe's large-scale structure is also influenced by the distribution of dark energy, a mysterious component that drives the accelerating expansion of the universe. Dark energy is thought to make up about 68% of the universe's mass energy density. But its nature and properties remain poorly understood, leaving scientists with more questions than answers. As we delve deeper into the universe's large-scale structure, we begin to notice a striking pattern. The distribution of galaxies and galaxy clusters is not uniform, but rather it follows a hierarchical pattern, with smaller structures merging to form larger ones. A process that has been unfolding over billions of years. This hierarchical structure is thought to have arisen from the gravitational collapse of tiny fluctuations in the universe's density, which were present in the early universe. The study of the universe's large-scale structure has also led to the discovery of massive galaxy filaments, which stretch across vast distances, sometimes exceeding 500 million light-years in length. These filaments are thought to have formed through the gravitational attraction of galaxies and galaxy clusters, and they provide a unique window into the universe's evolution and the interplay between matter and energy. One of the most impressive examples of a galaxy filament is the Sloan Great Wall, a vast structure that stretches over 137 billion light-years across the universe. This massive filament is composed of thousands of galaxies and galaxy clusters, and it provides a striking example of the universe's large-scale structure. With its intricate web-like pattern and vast, empty regions, as we continue to explore the universe's large-scale structure, we are reminded of the awe-inspiring complexity and beauty of the cosmos, a beauty that is both humbling and unsettling. As we realize the universe's indifference to our existence. The universe is a vast and unforgiving place where gravity and expansion have shaped the cosmos into a complex and ever-changing landscape. The study of the universe's large-scale structure is an ongoing effort, with scientists using advanced telescopes and computational simulations to unravel the mysteries of the cosmos. As we push the boundaries of our knowledge, we are forced to confront the limits of our understanding and the vast expanse of the unknown that still lies before us. And it is here, at the edge of this unknown, that we are faced with a profound question: what lies beyond the observable universe? In the vast expanses of space and time that stretch out before us, waiting to be explored. As we stand at the edge of this unknown, gazing out into the vast expanse of space and time, we are reminded of the fundamental role that stars play in shaping the universe as we know it. Stars are the crucibles of heavy elements, forging the very building blocks of life within their cores. From the molecular clouds that give birth to new stars, to the supernovae explosions that mark their demise. The life cycle of stars is a complex and fascinating process that has captivated scientists and theorists for centuries. One of the most intriguing aspects of star formation is the way in which these celestial bodies influence the chemical composition of the universe. As stars are born, they begin to fuse hydrogen into helium, releasing a vast amount of energy in the process. This energy, in turn, drives the formation of heavier elements, such as carbon, nitrogen, and oxygen, which are essential for the creation of life as we know it. However, honestly, nobody really knows why the universe seems to favor the creation of certain elements over others. The journey of a star from birth to death is a long and winding one, spanning millions of years. It begins in the depths of a molecular cloud, where gravity causes the cloud to collapse in on itself, forming a protostar. As the protostar continues to collapse, its core begins to heat up, eventually igniting the fusion of hydrogen into helium. This marks the birth of a new star, which will then embark on a journey that will take it through various stages of evolution, including the main sequence, the red giant branch, and finally, the white dwarf cooling track. But what happens when a star reaches the end of its life? In the case of massive stars, the answer is a supernova explosion, a catastrophic event that releases an enormous amount of energy into the surrounding space. These explosions are so powerful that they can be seen from millions of light years away. And they play a crucial role in shaping the chemical composition of the universe. By dispersing heavy elements into the surrounding space, Supernovae explosions provide the raw materials for the formation of new stars, planets, and, potentially, life itself. The study of star formation and the life cycle of stars is an active area of research, with scientists using a combination of observations, simulations, and laboratory experiments to unravel the mysteries of these celestial bodies. From the detection of protostars in molecular clouds to the analysis of supernovae remnants, each new discovery provides a valuable insight into the complex and fascinating process of star formation. And yet, despite the significant progress that has been made, there is still much that we do not understand. Honestly, the universe is full of mysteries. And the life cycle of stars is just one of the many puzzles that scientists are still trying to solve. As we continue to explore the universe, we are constantly reminded of the awe-inspiring scale and complexity of the cosmos. The life cycle of stars is just one aspect of this vast and intricate web. And it is a testament to the power and beauty of the universe that we are still able to learn so much from these celestial bodies. And so, as we stand at the edge of this unknown, gazing out into the vast expanse of space and time, we are forced to confront the limits of our understanding and the vast expanse of the unknown that still lies before us. The universe is a mysterious and often violent place, and it is this very mystery that draws us in, compelling us to continue exploring, to continue seeking answers to the profound questions that have haunted humanity for centuries. And it is here, in the silence of the universe, that we are left to ponder the ultimate question: what lies beyond the edge of our understanding, waiting to be discovered? The answer, much like the universe itself, remains shrouded in darkness, leaving us with only one certainty: the unknown is vast, and it is waiting. As we stand at the precipice of this unknown, the question of whether we are alone in the universe becomes increasingly pressing, driving us to search for answers in the vast expanse of space that surrounds us. The conditions necessary for life, as we currently understand them, are stringent: a stable star, a habitable planet, and the presence of liquid water. Yet, despite these narrow parameters, the discovery of exoplanets has revealed a universe teeming with potential, where thousands of worlds, each with its own unique characteristics, orbit stars that are similar to our own. Honestly, nobody really knows why these planets are so abundant. But their existence has sparked a new era of research. As scientists scramble to determine whether any of these distant worlds might harbor life, the search for life beyond Earth is a complex and multifaceted endeavor, requiring the coordination of astronomers, biologists, and geologists, each bringing their own expertise to the table. One of the most significant breakthroughs in this field has been the development of advanced telescopes, capable of detecting the faint signatures of biomarkers in the atmospheres of exoplanets. These biomarkers, such as oxygen, methane, or carbon dioxide, can be indicative of biological processes, and their presence could provide the first hints of life beyond our planet. However, the detection of these signatures is a daunting task, as it requires an incredibly high degree of precision and sensitivity, making it a challenging and often frustrating pursuit. Despite these challenges, the discovery of exoplanets has opened up new avenues of research, allowing scientists to study the formation and evolution of planetary systems in unprecedented detail. The Kepler Space Telescope, for example, has revealed a staggering array of planetary architectures. From compact systems with multiple small planets to more expansive systems with large gas giants. These findings have significant implications for our understanding of the universe, as they suggest that the formation of planetary systems is a complex and highly variable process, influenced by a multitude of factors, including the mass of the star, the presence of disk material, and the interactions between planets. As we continue to explore the universe, we are forced to confront the reality that our own solar system may be just one of many, and that the conditions that allow for life on Earth may be far more common than we ever could have imagined. The search for life beyond Earth is also driven by the discovery of extremophiles, organisms that thrive in environments that were once thought to be inhospitable to life. These microbes, found in the hottest, coldest, and most toxic environments on our planet, have expanded our understanding of the conditions necessary for life, revealing that it can exist in a wide range of contexts. The existence of these extremophiles has significant implications for the search for life beyond Earth, as it suggests that life may be able to thrive in environments that are far more hostile than those found on our own planet. Honestly, nobody really knows what the limits of life are. But the discovery of these organisms has opened up new possibilities for the search for life beyond Earth, and has raised hopes that we may one day find evidence of life on other planets. As we continue to explore the universe, we are reminded of the profound mysteries that remain unsolved, and the vast expanse of the unknown that lies before us. The search for life beyond Earth is a testament to human ingenuity and curiosity, driving us to push the boundaries of what is thought to be possible, and to seek answers to the profound questions that have haunted humanity for centuries. And yet, as we stand at the threshold of this new frontier, we are forced to confront the reality that the universe is a vast and often inhospitable place, where the search for life may be a long and difficult journey, with no guarantee of success. As we embark on this journey, we are left with only one certainty: the unknown is vast, and it is waiting. But what if, despite all our efforts, we are not alone in the universe? What if, as we search for life beyond Earth, we stumble upon something that challenges our very understanding of the cosmos, and forces us to re-examine our place within it? The answer, much like the universe itself, remains shrouded in darkness, leaving us with only one option: to continue exploring, to continue seeking answers, and to confront the ultimate question, are we alone in the universe? As we stand at the precipice of this existential inquiry, the universe's vast expanse stretches out before us like an endless, star-studded canvas, whispering secrets of its ultimate fate. The cosmos, in its infinite complexity, is a labyrinth of mysteries. And we are but mere travelers, navigating the twists and turns of space and time. Honestly, nobody really knows why the universe is expanding at an accelerating rate. But we do know that this expansion will eventually lead to a point of no return. A moment when the fabric of space itself will be torn asunder. In this desolate future, the universe will have reached its ultimate state, a cold, dark, and lifeless expanse, devoid of any semblance of energy or matter. This is the inevitable heat death, a fate that awaits all closed systems, including our own universe. The laws of thermodynamics dictate that entropy will always increase, that energy will always be lost, and that the universe will eventually succumb to the ravages of time. And yet, despite this bleak prognosis, there is a glimmer of hope. A possibility that our universe is but one of many. A mere bubble in a vast multiverse. The concept of the multiverse is a tantalizing one. A notion that there exist an infinite number of universes, each with its own unique set of physical laws and properties. It is an idea that challenges our understanding of reality, that forces us to re-examine our place within the grand scheme of things. But what if this multiverse is not just a theoretical construct, but a real, tangible entity? A realm that exists in parallel to our own. What if, as we explore the cosmos, we stumble upon evidence of this multiverse, and are faced with the daunting task of comprehending its infinite complexity? The search for evidence of the multiverse is an ongoing one, with scientists using a variety of methods to detect the existence of parallel universes. One such method involves the study of cosmic microwave background radiation, the residual heat from the Big Bang, which may hold clues to the existence of the multiverse. Another approach involves the use of gravitational waves, ripples in the fabric of space-time that may be used to detect the presence of parallel universes. As we delve deeper into the mysteries of the multiverse, we are forced to confront the ultimate question. What is the role of human existence within the grand scheme of things? Are we but mere observers, passive witnesses to the unfolding of the cosmos? Or are we active participants, capable of shaping the course of events through our actions? Honestly, nobody really knows. But what we do know is that our existence is but a fleeting moment in the grand tapestry of time. A moment that will soon be lost to the sands of eternity. In this vast, uncaring universe, we are but a small, insignificant speck. A momentary flicker of consciousness in an infinite expanse of space and time. And yet, despite this crushing insignificance, we are driven to explore, to discover, and to push the boundaries of human knowledge. We are driven by a primal urge to understand, to comprehend the mysteries of the cosmos, and to find our place within the grand scheme of things. But as we stand at the edge of this existential precipice, staring out into the void, we are met with an unsettling realization. The universe is indifferent to our existence. It is a vast, uncaring expanse, devoid of purpose or meaning, a realm in which we are but a small, insignificant part. And in this moment, we are forced to confront the ultimate truth: that our existence is but a brief, shining moment in the grand narrative of the cosmos. A moment that will soon be lost to the sands of time. The universe will continue to expand, to evolve, and to change, long after we are gone, leaving us with only one haunting question: what will be the ultimate fate of our cosmos? And what will be our place within its grand scheme? As we ponder the ultimate fate of our cosmos, we are reminded that the universe's expansion is not just a phenomenon, but a fundamental aspect of its nature. A nature that is still being unraveled by scientists using the latest findings from telescopes, space missions, and particle accelerators. The vast expanse of space and time is being probed by an array of sophisticated instruments, from the Hubble Space Telescope to the Large Hadron Collider, each providing a unique window into the workings of the universe. Honestly, nobody really knows why the universe is expanding at an accelerating rate. But the evidence from distant supernovae, the cosmic microwave background radiation, and the distribution of galaxies all point to the same conclusion: the universe is getting bigger. And it's getting bigger fast. The observations of Type Ia supernovae, for instance, have been instrumental in shaping our understanding of the universe's expansion. These cosmic events, which occur when a white dwarf star reaches a critical mass and explodes, have been used as standard candles to measure the distance to far-flung galaxies. By analyzing the light curves of these supernovae, scientists have been able to infer the expansion history of the universe, revealing that the rate of expansion has been increasing over the past few billion years. This discovery has sent shockwaves through the scientific community, challenging our previous understanding of the universe's evolution and raising more questions than answers. What is driving this acceleration? Is it the result of some unknown form of energy? Or is it a manifestation of some deeper aspect of the universe's nature? The search for answers has led scientists to explore new frontiers. From the properties of dark energy to the behavior of gravity on large scales. The Sloan Digital Sky Survey, for example, has mapped the distribution of galaxies across vast swaths of the universe, revealing a complex web of galaxy filaments and voids that stretches across billions of light years. By analyzing the patterns and structures that emerge from these observations, Researchers have been able to constrain models of the universe's evolution, shedding light on the interplay between matter and energy that has shaped the cosmos over billions of years. And yet, despite these advances, the universe remains a deeply mysterious place, full of hidden secrets and unseen forces that continue to intrigue and unsettle us. One of the most fascinating areas of research in modern cosmology is the study of gravitational lensing, a phenomenon in which the light from distant galaxies is bent and distorted by the gravitational field of intervening matter. By analyzing these distortions, scientists have been able to map the distribution of mass and energy across the universe, revealing a complex landscape of dark matter halos and galaxy clusters that stretches across the cosmos. Honestly, the sheer scale and complexity of this landscape is almost impossible to comprehend. A reminder that the universe is a vast and intricate system that is still far from being fully understood. And yet, it is precisely this complexity that makes the universe so fascinating. A grand puzzle that continues to challenge and inspire us as we strive to unravel its secrets. As we continue to explore the universe, we are constantly reminded of our own limitations and the provisional nature of our knowledge. The universe is a vast and sprawling system, full of mysteries and uncertainties that continue to haunt us. And yet, it is precisely this uncertainty that drives us forward. A reminder that the universe is a frontier that is still waiting to be explored. A frontier that holds the key to some of the most fundamental questions about our existence and our place within the grand scheme of things. But what lies beyond the horizon of our current understanding? What secrets remain hidden, waiting to be uncovered by the next generation of scientists and explorers? The universe, it seems, is still full of surprises. And we are about to stumble upon one of the most profound and unsettling discoveries of all, as we stand at the threshold of this uncharted territory. The sheer scale of the universe begins to sink in. A daunting realization that challenges our perception of distance and our place within the grand expanse. The numbers are staggering. Billions of galaxies, each containing billions of stars, stretching out across vast expanses of space and time. Honestly, nobody really knows why the universe is so vast, but one thing is certain. It's a scale that's difficult for the human mind to comprehend. Consider this. The nearest star to our Sun, Proxima Centauri, is about 424 light-years away. That means that if we were to travel at the speed of light, it would take us over 4 years to reach our closest celestial neighbor. But what about the galaxies that are billions of light-years away? The light we see from them today has been traveling through space for billions of years. A cosmic messenger from a bygone era. It's a reminder that the universe is not just vast, but also ancient, with a history that stretches back to the dawn of time itself. As we delve deeper into the mysteries of the universe, we begin to realize that our perception of distance is not just a matter of physics, but also of psychology. The human brain is wired to respond to threats and opportunities that are close at hand, not to distant galaxies or abstract concepts like dark matter and dark energy. And yet, it's precisely this ability to contemplate the vastness of the universe that sets us apart from other species. We are capable of abstract thought, of imagining the unimaginable, and of pondering the mysteries of the cosmos. But what happens when we confront the reality of our own insignificance in the grand scheme of things? The universe is indifferent to our existence. A vast and uncaring expanse that is governed by laws of physics, not by human emotions or desires. It's a sobering thought, one that can evoke feelings of existential dread and cosmic anxiety. And yet, it's precisely this awareness of our own mortality and the fleeting nature of human existence that can inspire us to reach for the stars, to explore the unknown, and to push the boundaries of human knowledge and understanding. As we navigate the complexities of the universe, we are forced to confront the limits of our own knowledge and understanding. Honestly, nobody really knows what lies beyond the horizon of our current understanding, or what secrets remain hidden, waiting to be uncovered by the next generation of scientists and explorers. But one thing is certain: the universe is full of surprises. And we are about to stumble upon one of the most profound and unsettling discoveries of all. The vast expanse of space and time stretches out before us like an endless ocean. A reminder that the journey of discovery is never truly complete, and that the universe will always remain a mystery, waiting to be unraveled. In the face of such uncertainty, we are left with more questions than answers. What lies at the edge of the observable universe? What secrets are hidden in the cosmic microwave background radiation? And what is the ultimate fate of the universe billions of years from now? The universe, it seems, is a puzzle with many missing pieces, and we are merely attempting to assemble the clues one by one, in the hopes of uncovering a deeper truth. As we continue to explore the universe, we are reminded of the importance of humility and the need to approach the unknown with a sense of awe and wonder. The universe is a complex and mysterious place, full of surprises and contradictions. And we are merely a small part of it. A fleeting moment in the grand tapestry of time. And yet, it's precisely this awareness of our own place within the universe that can inspire us to reach for the stars, to explore the unknown, and to push the boundaries of human knowledge and understanding. But for now, we are left with the quiet dread of the unknown. The realization that the universe is a vast and uncaring expanse, and that we are merely a small and insignificant part of it. The darkness of space stretches out before us, a reminder of the mysteries that remain unsolved, and the secrets that remain hidden, waiting to be uncovered by the next generation of scientists and explorers. And so, we stand at the threshold of this uncharted territory, frozen in a moment of cosmic awe, unsure of what lies ahead. but certain that the journey will be worth it. As we stand at this threshold, the darkness of space stretches out before us like an endless, starry canvas. A reminder that our existence is but a small, intricate brushstroke on the grand tapestry of time. The quiet dread of the unknown that settles in the pit of our stomachs is a primal, existential fear that has haunted humanity since the dawn of civilization. It is a fear that has driven us to create, to imagine, and to explore. As we desperately try to make sense of our place within the vast, uncaring expanse of the universe, from the ancient myths of creation to the modern science fiction that dominates our screens, the concept of the universe has been a constant source of fascination and inspiration for human culture. We see it in the works of authors like Isaac Asimov and Arthur C. Clarke, who wove complex, futuristic worlds that explored the possibilities of human existence among the stars. We see it in the iconic, special effects-driven blockbusters that have become a staple of modern cinema, films like 2001, A Space Odyssey, and Interstellar, that use the vastness of space as a backdrop for exploring fundamental questions about human nature and our place in the universe. But our fascination with the universe is not just about entertainment, it is also about understanding. It is about trying to make sense of the mysterious, often terrifying forces that shape the cosmos. Honestly, nobody really knows why the universe is expanding at an accelerating rate, or what dark matter and dark energy are, but we are driven to find out. We are driven to explore, to discover, and to push the boundaries of human knowledge. Even as we are humbled by the realization that the universe is a vast, complex, and often incomprehensible system that may be beyond our full understanding. The search for answers has led us to create complex, sophisticated theories like the Big Bang, which suggests that the universe began as a singularity, an infinitely hot and dense point that expanded rapidly around 13.8 billion years ago. It has led us to develop powerful tools like telescopes and space probes, which have allowed us to study the universe in unprecedented detail. From the majestic swirl of galaxy clusters to the faint, whispery signals of distant stars. And yet, despite these advances, we are still left with more questions than answers. Still left to ponder the mystery of our existence and the meaning of the universe. One of the most fascinating examples of how the concept of the universe has influenced human culture is the way it has shaped our art and literature. From the poetic cosmic visions of William Blake to the futuristic sci-fi landscapes of Sid Mead, the universe has been a constant source of inspiration for artists and writers. We see it in the works of musicians like David Bowie and Pink Floyd, who used the vastness of space as a metaphor for exploring the human condition. We see it in the iconic, surreal landscapes of filmmakers like Stanley Kubrick and Christopher Nolan, who have used the universe as a backdrop for exploring fundamental questions about human existence and the nature of reality. But what is it about the universe that inspires us so? Is it the sheer scale of the cosmos, the fact that we are but a small, insignificant part of a vast, uncaring expanse? Or is it something deeper, something that speaks to our fundamental human nature? Honestly, nobody really knows. But it is clear that the universe has a profound impact on our culture, our art, and our literature. It is a reminder that we are part of something much larger than ourselves, something that transcends our petty squabbles and national borders. As we continue to explore the universe, to study its mysteries and to ponder its meaning, we are forced to confront our own limitations and vulnerabilities. We are forced to confront the fact that we are but a small, fragile species, living on a small, fragile planet, in a vast, uncaring universe. And yet, it is this very realization that gives us the strength to carry on, to explore, to discover, and to push the boundaries of human knowledge. It is this realization that reminds us of the infinite possibilities that lie before us, and the incredible journey that awaits us as we venture forth into the unknown. The universe is a complex, mysterious, and often terrifying place, but it is also a place of incredible beauty and wonder. From the majestic swirl of galaxy clusters to the faint, whispery signals of distant stars, the universe is a vast, intricate tapestry that is full of surprises and mysteries waiting to be uncovered. And as we stand at the threshold of this uncharted territory, frozen in a moment of cosmic awe, we are reminded that the journey ahead will be worth it, that the secrets we uncover will be worth the risk, and that the universe will always be a source of inspiration, fascination, and wonder. But what lies ahead as we venture forth into the unknown? And what secrets will we uncover as we continue to explore the vast, mysterious expanse of the universe? As we venture forth into the unknown, the vast expanse of the universe unfolds before us like an endless, star-studded canvas, painted with the vibrant colors of celestial bodies, galaxies, and nebulas. Each one a reminder of the awe-inspiring beauty and complexity that lies at the heart of existence. The journey ahead will be long and arduous, filled with twists and turns that will challenge our understanding of the cosmos and our place within it. Honestly, nobody really knows what secrets the universe holds, or what mysteries lie hidden in the depths of space and time. But one thing is certain: the intersection of science and philosophy will be the guiding force behind our quest for knowledge. As we seek to unravel the intricate threads that weave together the fabric of reality, the universe, in all its vastness and complexity, is a puzzle that has puzzled philosophers and scientists for centuries. From the ancient Greeks to modern-day cosmologists, the question of the universe's origin, nature, and ultimate fate has been a topic of intense debate and speculation. And yet, despite the many advances that have been made in our understanding of the cosmos, there remain many unanswered questions, many unresolved mysteries that continue to haunt us. What is the nature of dark matter and dark energy, those mysterious components that make up about 95% of the universe? What lies beyond the reaches of our observable universe, in the vast expanse of the multiverse, where an infinite number of universes may exist, each with its own unique laws of physics and properties? As we delve deeper into the mysteries of the universe, we begin to realize that the line between science and philosophy is often blurred. The questions that scientists ask about the universe are often rooted in philosophical assumptions and biases, and the answers that they seek are often influenced by their own personal beliefs and values. And yet, it is precisely this intersection of science and philosophy that makes the study of the universe so fascinating, so rich in possibilities and perspectives. For in the end, it is not just about understanding the universe, but about understanding ourselves, our place within the grand scheme of things, and the meaning and purpose of our existence. Consider, for example, the concept of time, which is a fundamental aspect of our experience of the universe. We measure time in terms of seconds, minutes, and hours, but what is time really? Is it an absolute objective feature of the universe, or is it a relative, subjective experience that varies from one observer to another? The answer to this question has profound implications for our understanding of the universe, and yet, it is a question that has been debated by philosophers and scientists for centuries, with no clear resolution in sight. Honestly, nobody really knows what time is or how it relates to the universe. And it is this uncertainty that makes the study of time so fascinating, so full of possibilities and perspectives. Another example is the concept of space, which is intimately connected with time. We think of space as a three-dimensional canvas, a backdrop against which the universe unfolds. But what is space really? Is it an absolute objective feature of the universe, or is it a relative, subjective experience that varies from one observer to another? The answer to this question has profound implications for our understanding of the universe, and yet, it is a question that has been debated by philosophers and scientists for centuries, with no clear resolution in sight. And it is precisely this uncertainty that makes the study of space so fascinating, so full of possibilities and perspectives. As we continue to explore the universe, we begin to realize that the questions we ask are often more important than the answers we seek. The universe is a complex, multifaceted entity, full of mysteries and wonders. And it is our questions, our curiosity, and our passion for knowledge that drive us forward, that propel us into the unknown. And so, we press on, driven by our insatiable curiosity, our desire to understand the universe and our place within it. But as we venture forth into the unknown, we are reminded that the universe is indifferent to our existence, that it is a vast, impersonal expanse governed by laws and principles that are beyond our control. And it is this realization that fills us with a sense of quiet dread, a sense of awe and wonder at the vast, mysterious expanse of the universe. As we stand at the precipice of this vast, impersonal expanse, we are forced to confront the reality that our existence is but a fleeting moment in the grand tapestry of time. The universe, indifferent to our presence, continues to expand, governed by laws and principles that are beyond our control. And yet, it is this very indifference that drives us to push the boundaries of our understanding, to develop technologies that allow us to probe the depths of space and unravel the mysteries of the cosmos. One such technological innovation is the Space Telescope, a marvel of modern engineering that has enabled us to study the universe in unprecedented detail. From the Hubble Space Telescope, which has captured stunning images of distant galaxies and nebulae, to the latest generation of telescopes, such as the James Webb Space Telescope, which is capable of detecting the faint light from the first stars and galaxies. These instruments have revolutionized our understanding of the universe. Honestly, nobody really knows why the universe is expanding at an accelerating rate. But with these telescopes, we are able to gather clues, to piece together the puzzle of the cosmos, and to gain a deeper understanding of the underlying laws and principles that govern its behavior. For instance, the Hubble Space Telescope has been used to study the expansion of the universe, providing valuable insights into the nature of dark energy, a mysterious component that makes up about 68% of the universe's total energy density. By analyzing the light from distant supernovae, scientists have been able to measure the expansion history of the universe, providing strong evidence for the existence of dark energy. This discovery has significant implications for our understanding of the universe, suggesting that the expansion of the universe is not slowing down, as one might expect, but is instead accelerating, driven by the repulsive force of dark energy. Another area of technological innovation is in the development of advanced propulsion systems, which will enable us to travel deeper into space, to explore the outer reaches of our solar system, and to visit other planets and celestial bodies. For example, NASA's Space Launch System, SLS, is a heavy-lift rocket that will provide the capability to send humans and cargo on deep space missions, such as to the Moon and Mars. This technology has the potential to revolutionize space travel, enabling us to establish a sustainable presence in space and to conduct scientific research and exploration on a scale that was previously unimaginable. Furthermore, advancements in materials science and engineering have enabled the development of new technologies, such as advanced life support systems, which will be crucial for long-duration space missions. For instance, the European Space Agency's ESA MELISSA Micro-Ecological Life Support System Alternative project is a closed-loop life support system that can recycle air, water, and waste, providing a sustainable solution for long-term space missions. This technology has significant implications for the future of space exploration, enabling us to send humans on extended missions to other planets and celestial bodies, and to establish a sustainable presence in space. In addition, the development of advanced robotics and artificial intelligence has enabled the creation of sophisticated spacecraft, such as the Curiosity rover, which has been exploring Mars since 2012. These robots are capable of conducting complex scientific experiments, navigating challenging terrain, and transmitting valuable data back to Earth, providing us with a wealth of information about the Martian environment and geology. Honestly, the potential of these technologies is vast, and it is likely that they will play a critical role in the future of space exploration, enabling us to conduct scientific research and exploration on a scale that was previously unimaginable. As we continue to push the boundaries of technological innovation, we are reminded that the universe is a vast, complex, and mysterious place, full of secrets waiting to be uncovered. And it is this realization that drives us forward, that propels us into the unknown. And that fills us with a sense of awe and wonder at the vast, mysterious expanse of the universe. But as we venture forth into the unknown, we are forced to confront the reality that there are still many unanswered questions, many mysteries that remain unsolved, and many secrets that lie beyond our current understanding. And it is this uncertainty that raises a profound question. What lies beyond the edge of our observable universe? And what secrets await us in the vast, uncharted expanse of the cosmos? As we stand at the precipice of this unknown, gazing out into the abyss of uncharted space, we are reminded that the universe is replete with enigmas that continue to intrigue and mystify us. The phenomenon of fast radio bursts, for instance, has left scientists scrambling to understand the origin and nature of these brief, intense pulses of energy that emanate from distant galaxies. Honestly, nobody really knows why these bursts occur or what could be causing them. But theories abound, ranging from the collapse of massive stars to the presence of advanced alien technology. The search for answers has led to a flurry of research, with scientists poring over data from telescopes and spacecraft, seeking to glean some insight into the underlying mechanisms that drive these bursts. One of the most compelling theories is that fast radio bursts are caused by the collapse of massive stars, which creates an enormous amount of energy that is released in the form of a burst of radio waves. However, this theory is still highly speculative, and scientists are working to gather more data to confirm or rule out this hypothesis. Another area of research that has garnered significant attention in recent years is the study of gamma-ray bursts, which are incredibly powerful explosions that occur when a massive star collapses in on itself. These bursts are so powerful that they can be seen from millions of light years away. And scientists believe that they may hold the key to understanding some of the most fundamental questions about the universe. including the formation of black holes and the creation of heavy elements. But despite the significant progress that has been made in understanding gamma-ray bursts, there is still much that remains unknown. For instance, scientists are still unsure what triggers these bursts, or how they manage to release such an enormous amount of energy in such a short period of time. Furthermore, the study of gamma-ray bursts is complicated by the fact that they are often obscured by gas and dust, making it difficult for scientists to get a clear view of the underlying mechanisms that drive these explosions. In addition to fast radio bursts and gamma-ray bursts, scientists are also working to understand the nature of dark matter and dark energy, which are thought to make up approximately 95% of the universe. Honestly, nobody really knows what these mysterious substances are or how they interact with normal matter. But scientists are working to develop new theories and models that can help explain their behavior. One of the most promising areas of research in this field is the study of gravitational lensing, which occurs when light is bent by the gravitational field of a massive object, such as a galaxy or a cluster of galaxies. By studying the way that light is bent by these massive objects, scientists can gain insights into the distribution of mass and energy within the universe, and potentially even detect the presence of dark matter and dark energy. However, the search for answers is not without its challenges. Scientists are forced to rely on indirect methods to detect dark matter and dark energy, as they do not emit or absorb any electromagnetic radiation, making them invisible to our telescopes. This has led to a range of creative solutions, from the use of gravitational lensing to the development of sophisticated computer simulations that can model the behavior of these mysterious substances. As we continue to explore the universe, we are reminded that there is still so much that we do not know. The universe is a vast and complex place, full of mysteries and enigmas that continue to intrigue and mystify us. And it is this uncertainty that drives us forward, that propels us to continue exploring, to continue seeking answers to the profound questions that have haunted humanity for centuries. In the end, it is the unknown that defines us. That drives us to push beyond the boundaries of what we thought was possible. As we stand at the edge of the unknown, gazing out into the abyss of uncharted space, we are reminded that the universe is a place of profound mystery and wonder, a place that continues to inspire and awe us. And it is this sense of wonder, this sense of awe, that will continue to drive us forward as we explore the vast expanse of the cosmos and uncover the secrets that lie within. The silence of the universe is almost deafening. The silence of the universe is almost deafening. It's a reminder that there's still so much we don't know, so much that lies beyond our current understanding. As we stand at the threshold of a new era in space exploration, we're poised to uncover secrets that have been hidden for billions of years. The next generation of space missions and telescopes will allow us to peer deeper into the universe than ever before. to study the first stars and galaxies, and to detect the faint whispers of gravitational waves. Honestly, nobody really knows what we'll find. The universe is full of surprises, and the more we learn, the more we realize how little we know. But that's what makes this journey so compelling, so thrilling. We're not just exploring the universe, we're exploring the unknown, and that's a fundamental part of the human experience. The upcoming James Webb Space Telescope, for example, will allow us to study the formation of the first stars and galaxies in unprecedented detail. We'll be able to see the light from these ancient objects, light that has been traveling through space for billions of years, and gain insights into the early universe that were previously impossible. The Square Kilometre Array, another upcoming telescope, will allow us to study the universe in even greater detail, to detect the faint signals of gravitational waves, and to study the properties of dark matter and dark energy. These missions will help us to better understand the universe's large-scale structure, to study the distribution of galaxies and galaxy clusters, and to gain insights into the fundamental laws of physics that govern the cosmos. But as we look to the future, we're also reminded of the challenges that lie ahead. The universe is a vast and complex place, and uncovering its secrets will require significant advances in technology and our understanding of the underlying physics. One of the biggest challenges we face is the detection of gravitational waves. These waves are ripples in the fabric of space-time, produced by massive cosmic events such as the collision of black holes or neutron stars. The Laser Interferometer Gravitational Wave Observatory, or LIGO, has already detected several gravitational wave events. But the next generation of detectors will allow us to study these events in even greater detail. We'll be able to learn more about the properties of black holes, the behavior of matter in extreme environments, and the fundamental laws of physics that govern the universe. As we look to the future, we're also reminded of the importance of international collaboration. The next generation of space missions and telescopes will require significant resources and expertise, and will likely involve collaboration between scientists and engineers from around the world. The European Space Agency's Euclid mission, for example, will study the distribution of galaxies and galaxy clusters, and will help us to better understand the properties of dark matter and dark energy. The NASA's Wide Field Infrared Survey Telescope, or WIFST, will study the formation of galaxies and the distribution of dark matter, and will help us to better understand the universe's large-scale structure. Honestly, the more we learn, the more we realize how complex and mysterious the universe is. The next generation of space missions and telescopes will help us to uncover some of the universe's secrets. But they will also likely raise new questions and challenge our current understanding of the cosmos. As we stand at the threshold of this new era in space exploration, we're reminded that the universe is a place of profound mystery and wonder. a place that continues to inspire and awe us. And it's this sense of wonder, this sense of awe, that will continue to drive us forward as we explore the vast expanse of the cosmos and uncover the secrets that lie within. But what if we're not alone in the universe? What if there are other civilizations out there watching us, waiting for us to make contact? The silence of the universe is almost deafening, but it may not be silent for much longer. As we stand at the threshold of this new era in space exploration, the silence of the universe is a reminder that we are not just searching for answers, but also for a sense of our place within the grand scheme. The vast expanse of the cosmos can be overwhelming, and yet, it's this very vastness that inspires us to ask profound questions about our existence and our responsibilities. Honestly, nobody really knows why we're driven to explore, to discover, and to push the boundaries of what's possible. But it's this drive that has led us to some of the most significant breakthroughs in human history. From the discovery of dark matter and dark energy to the detection of exoplanets and the search for life beyond Earth. As we reflect on the profound impact that understanding the universe can have on our daily lives, our societies, and our future, we begin to realize that the cosmic perspective is not just a luxury, but a necessity. It's a reminder that our problems, our concerns, and our fears are not unique to us, but are part of a larger cosmic narrative that's still unfolding. The universe is indifferent to our existence, and yet, it's this very indifference that forces us to confront our own mortality, our own limitations, and our own place within the grand scheme. By embracing this cosmic perspective, we can begin to see the world in a new light, as a complex, interconnected system that's part of a much larger whole. Consider the case of the Earth's climate crisis, which is often viewed as a local problem. A problem that's unique to our planet. But from a cosmic perspective, the Earth's climate crisis is just one example of a much larger phenomenon. A phenomenon that's repeated throughout the universe as planets and stars are born, live, and die. By studying the formation and evolution of planets, we can gain insights into the complex interplay between a planet's atmosphere, its geology, and its biology, and how these factors contribute to the emergence of life. The discovery of exoplanets, for example, has revealed that planets can exist in a wide range of sizes, compositions, and orbits, and that the conditions for life can be met in many different ways. As we explore the universe, we're forced to confront our own limitations, our own biases, and our own assumptions. We are forced to question what we think we know and to challenge our own understanding of the world. This is a difficult, often uncomfortable process, but it's also a necessary one. As we strive to gain a deeper understanding of the universe and our place within it. By embracing this cosmic perspective, we can begin to see the world in a new light, as a complex, interconnected system that's part of a much larger whole. And it's this perspective that will ultimately drive us forward. As we explore the vast expanse of the cosmos and uncover the secrets that lie within, the cosmic perspective is not just a philosophical concept, but a practical tool that can be applied to our daily lives. By considering the long-term consequences of our actions, we can make more informed decisions about how to manage our resources, how to protect our environment, and how to ensure the survival of our species. For example, the search for renewable energy sources, the development of sustainable technologies, and the conservation of natural habitats are all critical issues that require a cosmic perspective. By considering the universe as a whole, we can begin to see the interconnectedness of all things and the importance of preserving the delicate balance of our ecosystem. As we look to the future, we're faced with a daunting array of challenges. From climate change to nuclear proliferation, from economic inequality to social injustice. But it's in the face of these challenges that the cosmic perspective can be most powerful. As a reminder that we're not alone, that we are part of a larger community that's connected by our shared humanity. By embracing this perspective, we can begin to see the world in a new light, as a complex, interconnected system that's part of a much larger whole. And it's this perspective that will ultimately drive us forward. As we explore the vast expanse of the cosmos and uncover the secrets that lie within, the silence of the universe is a reminder that we're still just beginning to scratch the surface of what's possible. As we stand at the threshold of this new era in space exploration, we're forced to confront the unknown, to confront the mysteries that lie beyond the reach of our current understanding. And it's in this unknown that we'll find the greatest challenges, the greatest opportunities, and the greatest rewards. The universe is a vast, uncharted territory, full of secrets waiting to be uncovered, full of mysteries waiting to be solved. And it's this sense of wonder, this sense of awe, that will continue to drive us forward as we explore the vast expanse of the cosmos and uncover the secrets that lie within. But for now, the silence of the universe remains, a reminder of the profound mystery that lies just beyond our grasp. As we stand at the threshold of this uncharted territory, the silence of the universe remains, a haunting reminder of the profound mystery that lies just beyond our grasp. The darkness that surrounds us is not just the absence of light, but the absence of understanding. A void that we've only begun to fill with the faint glow of knowledge. And yet, it's in this darkness that we've discovered some of the most fascinating phenomena. From the eerie glow of distant galaxies to the mysterious dance of black holes. The journey through the vast expanse of the universe has been a humbling experience. A reminder of our own insignificance in the grand scheme of things. We've seen the birth and death of stars, the collision of galaxies, and the endless expansion of the cosmos. We've witnessed the beauty of supernovae, the majesty of neutron stars, and the awe-inspiring power of gamma-ray bursts. And through it all, we've been forced to confront the limits of our understanding, the boundaries of our knowledge, and the profound mysteries that remain unsolved. As we look out into the universe, we're reminded of the endless possibilities that await us. The discovery of exoplanets, the detection of gravitational waves, and the exploration of the cosmic microwave background radiation have all opened up new avenues of research, new areas of study, and new questions to be answered. Honestly, nobody really knows what lies beyond the edge of the observable universe, what secrets are hidden in the vast expanse of space and time. But it's this sense of wonder, this sense of awe, that drives us forward. That pushes us to explore, to discover, and to understand. The universe is a complex, dynamic, and ever-changing system, full of mysteries waiting to be solved. From the intricate dance of celestial mechanics to the subtle interplay of quantum forces, the universe is a vast, interconnected web of relationships and processes. And as we explore this web, we're beginning to uncover the hidden patterns, the underlying structures, and the fundamental laws that govern the behavior of the cosmos. But with each new discovery, we're also forced to confront the limitations of our understanding, the provisional nature of our knowledge, and the profound uncertainties that remain. As we stand at the threshold of this new frontier, we're reminded of the profound impact that the universe has on our daily lives, our societies, and our future. The exploration of space, the study of the cosmos, and the pursuit of knowledge have all become essential aspects of our shared human experience. They've inspired generations of scientists, engineers, and explorers, driven innovation and technological advancement, and expanded our understanding of the world and our place within it. And as we look out into the universe, we are reminded of the infinite possibilities that await us, the endless opportunities for discovery, and the profound mysteries that remain to be solved. But what lies beyond the edge of the observable universe? What secrets are hidden in the vast expanse of space and time? Honestly, nobody really knows, and it's this profound uncertainty that drives us forward. That pushes us to explore, to discover, and to understand. The universe is a vast, uncharted territory, full of mysteries waiting to be solved, full of wonders waiting to be discovered. And as we stand at the threshold of this new frontier, we're reminded of the endless possibilities that await us, the infinite mysteries that remain to be solved, and the profound impact that the universe will have on our future. But for now, the universe remains a profound mystery, a vast expanse of unknown, and a reminder of the infinite possibilities that await us. As we embark on the next great journey of discovery, and the universe whispers its final secret,